Okay, apologies everyone. Sorry for the technical difficulties here. So how many of you have started milestone 2 already? Okay, how's it going so far? Good? Easy, bad, difficult? Okay, cool. So yeah, if you haven't started, I recommend starting it now. Like start as early as possible. There are there is a big learning curve in this milestone, so don't leave it till the end. A lot of students find it quite a bit of fun, but if you leave it till the end and cram it in the last 3 days, it's not going to be as fun because it's going to be a lot of stress. Okay, so last lecture we talked about graphics APIs and what graphic API we're using in this course. The first thing we said that you need to do with graphics is to open the window that you are going to draw on. And here I'm basically showing some code to do so. If you've attended the tutorials this week, basically it goes in details into a lot of ECE297 specific functionalities. I'm just going to go over briefly about over these and discuss the most important parts. Okay, so the first thing here is to write your draw map function. You cannot change the name of this function. This is the function that we provide you with the skeleton code when you do ECE297 init 2. And our unit tests also invoke this function, so you cannot change the name. And this is the function you will invoke from your main executable. Okay, so what you need to do in this function is to first create an object called settings. It's an ECE297 object. And in this settings, you specify several things about the window that you're going to load. In the skeleton code we've provided you with a UI file called main.ui. This UI file is basically an XML file that it's human readable, and we predefine some buttons for you and a specific layout for the window that you will work on. Now you're free to change this, and that's part of the extra feature, but like the initial layout is under the main.ui. Okay, and then you provide the name for an identifier for your main window and the main drawing area, which is what we call the canvas. And you pass this settings object to the application object of ECE297. This application object will live throughout the whole program, and through it you can basically draw a lot of different things. The second part is to define your initial words. Basically, you need to tell ECE297 what are your initial coordinates of the drawing area that you're going to draw on. In this case, we're just doing a quick example. And we're writing from 0, 0, which is the bottom left corner, to 1100, 1150, which is the top right corner. Okay, and the final most important thing is to pass to ECE297 the main redraw function. So remember when we talked about graphics in the previous lecture, we said that ECE297 or any application, graphics application library basically keeps drawing the screen over and over again. And it does this by looking at what we call the callback function that's responsible to do so. In this case, we call this the callback function draw main canvas. So we pass it to the ECE297 along with the initial word coordinates that we specified. Okay, so far ECE297 doesn't know what it's going to draw. All it knows that there is one draw function that it will call over and over again, and this is called draw main canvas. Any questions so far? Nope. Okay. So yeah, again, this is the coordinate system, and this is the name of the main callback function that it will keep calling. Okay. At the end of the draw map function, the last line is we call application.run. Sorry, it's not the last line. You can do stuff after it, but application.run basically will open up the main window, and it will keep running until you either click proceed on the main window or like close the graphics interface. And if you notice here that we pass 4 different parameters to this application.run. Now, you can pass null pointers here, and basically it will not do anything. But if you remember in the previous lecture, we talked about callbacks, and that with graphics, you want it to be dynamic and respond to user input whenever they click on the mouse, they click on the keyboard, or anything else. So ECE297 run function accepts 4 different kinds of callback functions. The first one is called initial setup, And this is called as soon as your window is created. So it's only called once at the beginning, once you launch application.run. And inside it, you can define extra graphics things that are not covered in the main.ui, for example. So you can add extra buttons if you want. You can add dialog boxes that will live throughout the program, etc. So these are things that you don't want in your main.ui layout, but you want it to be added after the program is created. Okay. Another callback function is, we're going to talk about all the different types of callback functions, but briefly, basically, one of them is act on mouse press. The name basically says that it will act, it will do something once the user presses on the mouse. And act on mouse move, if you are hovering over your map, for example, and you want to highlight certain things, you can do so inside this function. And the last one is act on key press, where this is the keyboard pressing. Okay, so I said here that you can pass a null pointer for any callback you don't want to use in your program. Any idea why? Why can we specify a null pointer instead of a function here? Yes, ECE297. Yeah. We might not want it. I'm asking basically, why does that work? Like, how is a pointer? How can a pointer replace a function name? It's a tough question. So like, you get a chocolate bar if you. Yeah, ECE297. Right. So you're taking 243 right now, sir, right? Okay, so in 243, they teach you that to go to another method, you basically do a jump instruction and jump to that method. In hardware, when we define a new function, we actually define a memory address. And when we say jump to that memory address, we're just going to a certain memory address and continue the instruction execution from there. So when we pass a null pointer, as you said, is that instead of that function pointer, we are just saying that the memory address is null, and there is nothing to jump to. So that's why we can replace null pointer with, function names with null pointers. Okay, so the main UI that we provide you looks like this. There are some buttons on the right, and these stay throughout the whole program. The default one comes with zoom in, zoom out, zoom fit, and proceed. This test is a button that we added in the example code that we give you in the quick start guide. I actually recommend going through that example because it tells you everything you need to know about the different methods that you're going to use in this milestone, okay, and how to use them. So when you click application.run, it will pop up this window, and it will only return once you click proceed or you press the X in here. The second main part is this canvas, and this is what we call the canvas. This is the main drawing area, and basically this is where you define your initial world coordinates, okay? And the last one is the message bar at the end. You can change the name if you want, and you can type whatever you want in here, and this is called the status message bar. Again, there are certain methods in the in ECE297 that allows you to change that text. Okay, so we talked about the main callback function that ECE297 will keep drawing over and over again, but so far it doesn't know what it's drawing. Okay, inside this draw main function, you can do whatever you want. So in ECE297, you cannot change the parameters that are passed to these callback functions. So even for the act on mouse press, even for the keyboard press, they all expect certain number of parameters in a certain order. In this case, the main draw function, whatever you call it here, it should expect a renderer object or a pointer to a renderer object. And this renderer object, basically, you use it to draw everything, to change the color, to draw a line, to draw a polygon, etc. Okay, so one way we talked about the different functions that you can do with ECE297. Some of them are called attributes. In attributes, you basically specify the color that you want, you specify the thickness of the pen that you want, etc. So to specify a color, for example, you basically call the set color, which is member method of this renderer object. Okay, and there are two ways to call it. Either you pass in the color, a predefined color from ECE297. There is a list of predefined colors. You can go to look at the header file and check each one of these. Or you can specify the RGB color. By RGB, we basically red, blue, red, green, blue. And you specify the value that you want that goes from 0 to 255. And once you mix them, basically a certain color pops up. The last parameter here is for transparency or opaque. So if you want it to be non-transparent, you set it to 255. This is the largest value. If you want to be fully transparent, basically it's not going to show anything. It's going to be 0. If you specify something in the middle, it will try to get the color from the underlying object, whatever you drew first, and then this new color, and it will try to blend them in so that it shows you, the pixel will show basically a mix of both. Okay? Now, it is probably fun to do things that are transparent, but it's usually slower. Why is that? Because it's doing more work to try and mix the two colors together, right? So if you really need it, yes, use it. If you don't need it, try to avoid it so that your code doesn't get slow. Okay. So to set a line width, basically this is in terms of pixels. So if you set line width to 3, this means that the line that I'm going to draw next will be 3 pixels wide. The set line dash, also you can specify whether you want it solid or dash. And all of these attributes are sticky. What do we mean by that? It means that they stay as long as you don't change them. So whatever you draw next until you change the color will be, for example, in this case, black. Okay? So these are the attributes. So what can we do? What can we draw? There are certain primitives that ECE297 provide you, and these are to draw a line, to fill a rectangle, to draw a polygon, to draw an image where you basically import an image from somewhere and draw it on the screen, etc. You can also add your own stuff if you want by going to the underlying library, which is the GTK, and that's part of the extra feature. We're going to talk about it later. Okay, any questions so far? Nope, okay. So I wanted to do a demo, but since my laptop is not working, I cannot access my account. So to go over the ECE297 example, I'll try to go over it offline and post a video of it. But basically, what I was going to do is to go over the. We gave you a quick start guide for ECE297 on Quarkus, along with an example code. This example code is like 500 lines of code that goes over every single method that you might use in this milestone. So, and it's well commented, so it's very detailed. It will tell you what every function does. So I really recommend that you go over this example, because I think the easiest way to learn graphics is to get your hands dirty with them and try to actually change things and see how things will work. One of the main things that I wanted to mention in the demo was that when you zoom in and zoom out, you will notice that the screen will, the coordinates will change. But there is a way in ECE297 if you want something to stick and not change throughout the process called screen coordinates. We'll go over it in a little bit, but I wanted to show you actually in the demo how it actually is fixed and doesn't change in size. Anyway, okay, so yeah, the coordinate system and the level of detail. So one of the challenges in this milestone is to figure out what are your coordinates in, that you're going to specify for the initial world. Remember, for the example I showed you is just goes from 0, 0 to some number, but I don't think that will work for any city because you're going to try and open your map for different cities across the world. The GTK library, which what ECE297 is built upon, and a lot of other graphics libraries, they all work in pixels. Why is that? It's a convention. I really don't know why they use pixels, but when they use pixels, basically they use the size of the screen to specify the coordinates. That goes from 0, 0 on the top left to the bottom right, whatever the size of, for example, in this case, it's 900 wide and 600 in height, okay? The problem with pixels is very hard to reason about how you're going to map your, for example, streets to pixels, okay? Like is this number of pixels enough for the street, etc. It's really tough. So what we provide you with in ECE297 is that you can specify your own coordinate system through the initial word coordinates, and that can be anything you want, okay? So if we want to draw in pixels, it's going to be difficult to figure out how to map the meters that we use in milestone 1, or like the latitude, longitude, and map it to pixels. So in ECE297, again, we specify the initial words in terms of any coordinate system you want. If you attend the tutorials this week, basically they go over this in details. But a logical coordinate system is to use the projection that we gave you in milestone 1. Remember, in milestone 1, we try to map the latitude and longitude of different cities to meters, to XY coordinates that is in meters over some flat surface of the Earth. Okay, and that's the logical thing to do, because now ECE297 has something called a transformation matrix. So whenever you change your coordinates, zoom in and zoom out, it will use that transformational matrix and try to map it to your initial word coordinates. So that's the system that you chose, and it will map whatever you draw to that system. Okay, so if we draw things in meters, that makes more sense. It makes more sense than pixels, and you can reason about, oops. You can reason about how things will look like, okay? So here I'm showing an example where like this is minus 2000 E3, and that's a reasonable initial word coordinate for the Toronto map, but you should not hard code this, because you will need to open this for different maps, and different maps will have different coordinate systems, okay? So you need to think about a way to figure out what is the maximum and minimum XY coordinates that you need for each city, and that's based on the latitude and longitude of the different intersections in that city. So remember in milestone 1, we did a little extra work in load map. You will need to do something similar and try to get that latitude and longitude of all different intersections and try to reason about what is your initial word coordinates will be, okay? Sometimes you specify initial word coordinates that you think that make sense for your city, because this is the maximum and minimum points, for example, in my city, but it doesn't maintain the aspect ratio of the screen, for example. And ECE297 is smart enough to detect this, and it will try to add a little bit to the coordinate system that you provided so that your image doesn't look distorted. So let's say that here the width is way bigger than the height, okay, and this doesn't look nice, or it looks distorted because the aspect ratio is very wide. So ECE297 will try and increase a little bit over the boundaries and will set your initial word coordinates to something that makes more sense in terms of aspect ratio. So like 16:9, for example. Okay, and your image will not look distorted anymore. Okay, so remember we talked about zooming, and ECE297 has the ability to zoom in, zoom out, or pan with your scroll bar. What it does is that whenever you zoom in, it will basically transform that. Again, there is something called the transformation matrix inside ECE297 code. It will take that transformation matrix along with what is the zoom level that it is right now, and try to find a new word coordinates for whatever it's going to show on the screen right now. And it keeps doing that, and it's quite fast in doing this. And basically, it will keep changing the mapping from world to pixel to whatever pixels it wants to show. Any questions so far? Probably this is new. Okay. Okay. So and when you zoom in, remember it will keep calling the main draw function, which what we called here draw main canvas, over and over again. Now you will think that, okay, why am I drawing everything while I'm zooming into a small portion of the city? And that's fair enough, because it's going probably to waste a lot of CPU cycles doing so. But ECE297 is smart enough to pre-clip things that are drawn outside the word coordinates. So if it detects if something has coordinates that are outside of whatever it's showing right now on the screen, it will not draw it and it will skip it. So it won't be as slow no matter what. Okay. Yeah, this is what I talked about in terms of CPU cycles. Okay, so another thing, this is regarding your own world coordinates. I talked about that you can fix things on the screen even if you zoom in and zoom out, and that's called screen coordinates. When we say screen coordinates, we mean we're going to draw in terms of pixels and not in our coordinates anymore. Okay, when you draw in pixels, no matter how much you zoom in, zoom out, whatever, the pixels will still be shown on the screen. So for example, let's say you want to show a scale of the map while you are zooming in and zooming out, and you don't want that part of the screen to move, okay? So one way to do so is to draw with screen coordinates, and ECE297 allows you to do that through a function called set coordinate system, sorry. And when you say that the coordinate system is going to be ECE297 screen, that means it's going, whatever it draws next is in terms of pixels, and it will understand that. And it will keep drawing in pixels until you change it back to, in this case, world, okay? So most of the things that you're going to draw in your milestone 2 are going to be in world coordinates, which is the coordinate system that you define at the beginning. But if you want to draw something else that stays fixed throughout the whole program, then change it to screen coordinates. Some students in previous years basically used that to, remember when when you play a game, for example, and there is this mini-map over the screen, and that mini-map doesn't move no matter what you zoom in and zoom out. So they drew a mini-map, for example, for the whole world while you're zooming in and zooming out. And that mini-map is drawn in screen coordinates, for example. So, okay. Okay, so that's regarding the coordinate system that you're going to use. Now, the main challenge in milestone 2, and we talked about it in the previous lecture, is to figure out the level of detail that you're going to show. Because we ask you that you need to show every single detail of the city. We need to show all street names, all intersections, etc. But at the same time, we need it to be smooth, okay? And if you draw everything at the zoomed out level, it's going to look messy because all of the street names will basically appear on the screen, and it's probably gonna show a black screen. And it's going to be very slow because you're drawing everything every single time, okay? So let's say that you drew everything, it's probably gonna look like that, and that's obviously not what we want. So that's one of the main challenges that we need to figure out, that you need to figure out how to handle. Okay, you need to decide when to draw things at a certain zoom level, for example. And ECE297 gives you a lot of utilities that will help you in determining this. Okay, so for example, when you write text on the screen, you can specify the font size. Okay, now this font size is in terms of points. I don't know why they choose points, not pixels, but you can think about it that every 10 points is around 1/7 of an inch. Okay, so when you draw the text, for example, and you define a point where you're going to draw it, it will try to draw it in that font size that you predefined, and it will keep doing that until you change the font size again. And remember, fonts are in screen coordinates. They stay fixed no matter what you zoom in or zoom out. It will always be, for example, in this case, 1/7 of an inch shown on the screen, okay? But what if this text is much longer than the street right now? Like I'm at the zoom out level of the city, the street is not showing properly, but the text stays there. It might be fine for one street, for example. Oh, this is good, awesome street. But like, if you keep doing it for every single street and loop over all of the streets, you will notice that it gets a lot messy quickly, okay? So ECE297 allows you to determine when to draw that by specifying boundaries to the text that you're going to draw in. And those boundaries are not in the screen coordinates anymore, they are in the world coordinates that you define. Okay. So what do I mean by this? So remember that here we specified the point that we want to draw and the text that we want to show. In addition, the method also accepts what we call optional parameters. If you remember in C++, we have a way to specify optional parameters to functions by setting a default value in the definition of that function. So by default, these bounds, bound x and bound y, are set to the maximum possible world coordinate, okay? This basically the whole map, the whole coordinate system that you chose, okay? So by keeping them to default, it will always show the text that you want, no matter how big it is, okay? However, if you set them to some reasonable value, then ECE297 will try to determine whether, in terms of pixels, the text that it's going to show bigger or smaller than the coordinates that you show. So it will try to map the coordinates or the world coordinates that you set on the bounds from coordinates to pixels, and then compares that to the text that it's going to show, because it knows how many pixels it needs to write that text. If that number of pixels is bigger than what we currently have, then it won't draw it. When you zoom in a little bit, that coordinate gets bigger in terms of pixels, and now it's able to draw it. Okay, so the text won't be drawn if it's wider or higher than these numbers in the current coordinate system, whether it's world or screen. Whoops, okay. So let's say in this case we specify that the street length is 200 meters long, for example. Then we pass this 200 meters to this draw text function. ECE297 will take that 200 meters, transform it to pixels at each zoom level. So if at the zoomed out level, maybe this 200 meters is around 1 pixel, okay? But it knows that to draw this text, it needs around 10, 15 pixels, for example, okay? So it won't draw it. When you zoom in a little bit, that number of pixels for the street will get bigger, because now it's able to show the street more clearly, and maybe it's able now to show the text. Is this clear? Yeah. Yes. Yeah. So there are methods in ECE297 that allow you to rotate the text, and you specify the angle that you want. In the ECE297 example, there are it shows you how to use that as well. Okay. Any questions? Yeah. So ECE297 is built on top of GTK. So all of these methods we define as part of the API that we provide you, right? We wrote on the methods, but in the background they are calling methods from the underlying GTK library. Yes, so it might not be as obvious how to use these in GTK, but there are ways to do it. Because we didn't implement anything new in ECE297. We just took the important things from GTK and made it easier to the user, okay? There is a quick start guide on how to use GTK, and it will, if you are interested, basically just read that. It will tell you how to do all of these things, okay? So other helpful utilities that you might want to use in this milestone is to, for example, get the visible world. Get visible world, basically it will tell you whatever coordinates are showing currently on the screen at which zoom level. So when you are at the zoomed out level, the maximum level, it's basically showing the whole initial world coordinates that you specified. When you zoom in a little bit, now it's clipping the boundaries, and get visible world will return the coordinates that are currently visible on the screen. You might want that to basically decide whether to draw certain things or not, okay? Another method is to get the visible screen. Okay, so notice the difference. Here it says get visible world. Here it says get visible screen. When we say screen, we always mean pixels, okay? So if you're working on the same screen over and over, like the actual monitor, I think this will return the same coordinates always, because it's always showing the number of pixels, the pixel size of the screen. The last one that is very important is called world to screen, and this basically returns a transformation from the world coordinates that you specify to the pixels. So here you can determine how many pixels are available to this coordinate system right now. So let's say that we usually use these two together. We get the visible world, whatever currently visible on the screen in terms of coordinate system. We transform it to pixels, and now we know how many pixels each, for example, a street will take, okay, at each zoom level, and then you decide whether you want to draw it or not, okay? So in this way, you can think about different ways to draw all of the details, but not all at once, but trying to think about different zoom levels. Okay, any questions so far? This is regarding all the main challenge in milestone 2. Yes? No, you can use both. So the basic features, you can do them all in ECE297. using GTK allows you, for example, to do things that are a bit more advanced. And like, for example, you can change the whole layout of the screen, okay? You can get rid of the buttons, you can add extra search bars, for example, to do like autocomplete stuff, etc. These things are a bit more advanced, are not available in ECE297, but they are available in GTK. So if you want to use that, you will end up using both, right? Okay. So we talked about the callback functions and why they are important, because they keep things dynamic in graphics and they give you the ability to respond to user input. So we're going to show an example here on how to do that. Okay. So this is, here we are defining a new function called act on mouse press. You can call it whatever you want, but you need to just pass in the function pointer to the application.run method. But remember, we talked about that we need the parameters should always be the same. So for any callback function that you need to write, ECE297 expects a certain order of parameters and certain type of parameters. So in this case, we need to pass in the main application pointer, okay, because this is how ECE297 figures out where to draw and what to draw. And event button object, this is basically, it does nothing until you press, for example, on a button. So when you press on a button on the screen, ECE297 detects that and it stores it in this event object, and you can use that to figure out whether a button was clicked or not, okay? And then the X and Y coordinates of where the mouse was clicked. And ECE297 will detect that and pass these parameters to you. So in this case, for example, here I'm not doing anything. I'm just saying that I want to print the X and Y coordinates that I clicked on. And I want to see the button that was clicked. If a button was clicked, then this event button will basically show you the ID of that button. If you go look at the header file, when you define a button, you will define an ID for that button, and you will use it throughout the whole program in your code. Okay, so why are these useful? For example, part of the specs that we tell you in milestone 2 is that we need the ability to click on an intersection and give you information on that intersection, okay? So you will probably implement this in a callback function to act on mouse press. Then right now, ECE297 doesn't know what you're going to draw. So remember in milestone 1, we had methods to get the closest point to closest intersection to a certain point, right? So you can use that method to figure out what is the closest intersection to the X and Y coordinate that I clicked on, and you can show information on that intersection, okay? You probably need to set a threshold on the radius to look for, because you don't want to click on the beginning of the city and show you an intersection at the end of the city, for example. Okay. And remember, these are all in world coordinates. They are in terms of meters, the coordinate system that you specify. Okay, so this is, again, ECE297 doesn't know what it's drawing. All it knows that it's drawing something, right? So it doesn't know what to do. You need to implement and tell ECE297 what it needs to do. So ECE297, basically, you will implement all of these inside the act on mouse press. This is what I just talked about. And for example, find the closest intersection and show whatever you want on it. Tutorial 6 basically goes over this in detail. So I recommend watching that if you haven't yet. And it also goes over other callback functions in terms of like you click on a keyboard, whatever. You can do whatever you want in this milestone. And that's what's fun about it. It's very open-ended. You can decide how much work you want to put. I don't recommend ignoring your other courses, but yeah, it's fun that you get to learn a lot from this milestone. Okay, so these are regarding the basic features. Now, in part of milestone 2, 5% of the mark is going towards extra features. And we provide you with a lot of different suggestions, but you're free to choose your own suggestions as well. And for example, some of these features is to change the layout. As I said, you can go to the GTK library. You can create extra buttons that will help you do certain things in the city. For example, remember when I showed you the demo last, oops. Yeah, there you go. Remember when I showed you the demo last lecture? I showed you like in our reference solution, for example, we have a button to show the subway lines and either hide them or show them on the map. We have buttons to, for example, hide the street names if we don't want them. So you're free to add these buttons, as many buttons as you want. If we had the chance to show you the demo, the ECE297 example library also shows you, ECE297 example code, sorry, also shows you how to add dialog boxes, for example, or like how to add drop-down menus if you want, and choose certain options. And then you will write callback functions to each of those drop-down methods to do certain things. Okay? So you can also update the message at the bottom of the screen, and I actually recommend so. And this helps you actually in testing as well, like to know that you clicked on this, show me this message, for example. And a more advanced stuff, again, is to modify the layout, for example, because the basic layout that we're showing you here is part of the main.ui file that we provide you. And if you look at it, it's a bit outdated. Like, it's kind of look old, doesn't look beautiful, but it's easy to use. So if you feel like you don't like it, go ahead and try to change it as well. You can add dialogues and other widgets. Widgets are basically programmed inside the GTK itself, and they have more aesthetics to them than these buttons. Okay? So if you're interested, again, see the quick start guide for GTK. It lists a lot of things that you need to know to how to change the layout, for example. And that's pretty much it. I will try to get the demo offline and post it for you guys. If you have any questions, let me know. If not, I think that's it for today. Thank you. And thanks for allowing me to use your PC.
I don't know why I kept going like just black and white there. Yeah, because this is. We got through it.